There are millions of wooden poles used in utility overhead networks in all countries throughout the world. These represent a huge investment for the network owners who have the responsibility of both installing and maintaining them. To replace poles such as these can be expensive and time-consuming, requiring specialised personnel and equipment. Yet to leave wooden pole networks unmanaged can result in high risk of unplanned failure and electricity supply outages. An expensive business, not to mention potential litigation issues. And yet, all too often, the need to replace a pole comes about because of this: decay. A decay area in wood that is caused by fungi has developed here, deep within the centre of the pole, as a result of exposure to both moisture and oxygen. Decay like this can develop anywhere in wood, where it is subject to the same conditions. When the moisture level in the wood rises to above 20%, one of the key conditions has been met in creating an ideal environment for fungi to grow, and the destruction process for the wood has then begun. Decay is not always easy to detect. Often, wood decay is hidden in a joint or crack, just below the ground or spreading internally, only to surface after major damage has already occurred. Can damage like this be prevented? The answer is yes. But there are several aspects that, collectively controlled, help in forming an overall wooden pole management strategy. An effective management plan can greatly assist in extending the life of wooden poles and structures, saving money spent on replacement costs, reducing risk of unplanned failures, and making the network more predictable and reliable by providing valuable information for a range of maintenance programs. At the centre of such a management plan is a wood preservative treatment program for in-service poles and structures, delivering control against the growth of decay, the major contributing factor in reducing the service life. Preschem, a specialist wood preservation company formed in Australia and now delivering products to many other countries, has developed a unique range of wood preservatives specifically designed for utility poles and structures. For the moment, let's take a look at some basic steps involved with inspecting wood for decay, in particular poles and structures. In this case, decay often forms in the area immediately below the ground line. This is the zone where sufficient levels of oxygen and moisture are available to create the environment for fungal growth, so inspection can focus in this area. A simple visual check and a series of sharp hits in the critical zone with a hammer can provide a good preliminary indication of the wood condition. Decaying wood will often make a very dull sound, whereas good sound wood usually has a distinctive ring. This method can often be done at minimal cost on low-risk poles, such as those installed within the last 5 years or thereabouts. To check the outside section of wood below the ground means digging around the base down to a level of between 200 millimetres and 500 millimetres. Careful examination of the surface using a scraper or probe will often expose any areas containing decay. Examination of the external surface is important because the outer annulus is the strongest section of the pole, and any large-scale decay could greatly weaken the structure. Inspection of the internal wood usually requires some form of drilling. This process can be done with a 12mm hole or smaller. consideration needs to be given as to which axis is best used for this inspection hole. The axis in line with the conductors will have the least amount of wind loading, so the impact of drilling in this line will be minimal. Drilling in the other axis at 90 degrees to the conductors will provide a better understanding of wood in the critical zone of the pole. But too many inspection holes here could eventually weaken the pole. Drilling is best done slowly, where the inspector can feel resistance to drilling, hear the crunching sound of the wood, and carefully examine the shavings as they are being removed by the auger. Any poor or decaying wood will usually be darker in colour and soft, such as these examples. See the difference between the good and decayed wood? A suitable calibrated gauge can be used in the inspection hole to help the inspector convert this information into a reading of good wood. This information will help the inspector classify the pole or structure as either serviceable or requiring replacement. There may be some cases where the inspector may find so little sound wood remaining that urgent action may be needed in the form of either replacement or temporary support. Permanent reinforcing systems are also available that are very quick to install, yet reinstate the structure or pole back to a serviceable condition, even if no sound wood remains at the ground line. Not only does inspection provide information about decay, but often evidence of termites can be detected either from the external digging or internal drilling. There are many specialised treatments available for treatment of termites, ranging from ground barriers to sophisticated techniques that are aimed at destroying the social structure of the colonies. Inspection is best done on a cyclic basis of somewhere between 4 and 10 years. This ground line inspection is often incorporated with other inspection functions such as pole top, vegetation, earthing and conductor clearances. This is where valuable information can be provided to network maintenance planners and the necessary repairs and maintenance programmed. A crossarm, such as this, or trees into the power lines may not yet be a problem, but can be dealt with before causing that unplanned failure or electricity outage. It is also important that accurate records of inspection are retained for future planning and reference. So, in summary, the key steps to inspection are: the fungus causing decay needs moisture and oxygen to live, and this is usually found just below the ground line. A careful check visually and hitting with a hammer provides a good preliminary assessment of the pole condition. Digging to between 200mm and 500mm will be needed to evaluate the external part of the wood in the critical zone just below the ground line. The surface must be cleaned and probed. Internal decay is best checked using a carefully positioned hole drilled towards the centre of the wooden pole or structure. Important information is gained during the drilling process that will be used to determine how much good wood is remaining. This includes resistance to drilling, sound, colour and smell of shavings. All this information can then be used to determine a pole classification. Inspection of other assets attached to the pole can also provide valuable information that can be used in other maintenance programs. Records of inspection findings will prove most useful in the future.